Welcome to Ground Control, and it's time for the show and tell tutorial on the brushless conversion on this little Eachine Mini P51D Mustang. You should already have access to the conversion log, which I posted this past Sunday. So I think between the conversion log and the show and tell, you shouldn't have any problem doing a brushless conversion of this plane or another plane, because they're all very similar. You know, the motor mounts might be a little different, placement of the servos might be different. You know, the distribution of the way the electronics are installed might be different, but you know, it's all pretty much the same. So I'm going to talk a little bit about it, and then I'm going to put up some close-up images on the screen. My camera is not very, my recording camera is no good at doing that. So I took some still images while I was doing the conversion and trying to take details of most of the steps along the way. So I will put those up on the screen as I'm talking about it. So normally what I would do is I would use acetone. I would use acetone to loosen the glue along the seams so that I could pull the parts out nice and clean. That's a pretty lengthy process. You have to apply it several times to get the glue softened up enough where you can pull the parts apart without tearing any foam. I didn't have time to do that, so I cut everything. I didn't use any acetone to loosen the glue this time. I cut everything along the seams. So the first thing you want to do is remove your prop from the existing, you know, motor and gearbox. And then I started right here at the top, right along the seam, all the way through. Just use the utility blade to cut that all the way through from where the canopy starts. And then I flipped it over, and then I cut it from this seam, right in front of the battery bay, the plastic battery bay, and I cut it all the way through to the nose. Then I did add some acetone to the tabs on the gearbox and motor mount. You don't want to rip the foam on the fuselage when you pull that out. So you do need to soften up that glue a bit before you can pull that mount and that motor out. The motor should push through the back of the gearbox. I just, you know, since my motor and gearbox needed to be replaced anyway, I just went ahead and pulled the entire assembly out and then just clip the motor wires off. The receiver brick is still good. I might use it for a different project on down the road. But I just disposed of the gearbox and the motor and kept the prop. So once you get that done, then it's time to work on removing the wing. I did the same thing with the wing. I used a utility blade. And you can see, you know, you've got this area right here that you need to cut loose, which is the front portion of the battery bay, because it protrudes past the front of the wing onto the fuselage. So I just used a utility blade to cut through that glue between the plastic and the bottom of the fuselage. And then if you look, there's a seam that goes right along the wing, right along that housing, and then it comes down on each side and at the leading edge of the wing, and then you flip it over and you can see the seams. And then there's a seam that goes all the way the length, you know, along the top curvature of the wing. So on both sides. So I just used a utility blade to cut all that loose. Go slow. Sometimes you'll have to make several passes to get all the way through the foam and all the way through all the glue. And then on the back, right here at the back of this raised housing for the air intake, of course you got to cut all the way across that on the back side. All right, so once that's done and you've got your wing removed, then you can also use some acetone or alcohol. I like acetone; it's a lot faster. It doesn't seem to harm the EPP foam. Then it'll be time for you to pull the receiver brick out. So the first thing you're going to do, you can see the pictures up there, is you're going to remove the screws that hold the servo arms on, remove the servo arms so you can disconnect those from the control linkages. And then you can use acetone to work on that receiver brick. That was the hardest part to get removed for me. It took a lot more effort to get the receiver brick on mine removed without damaging the foam than it did the motor and gearbox housing. So you may have to apply acetone to that several times to get that glue softened up enough to where you can leverage that receiver brick out of there without damaging the foam. So that's going to be the next thing. So once you get that done, that pretty much concludes disassembly of the plane. In my conversion, I use the stock aileron servo. All I had to do was replace the connector on the end of the cable to a connector that fit the sockets in my micro receiver, and that's all I had to do. My linkage and everything was the same. I didn't have to change any of the linkage or anything. All I had to do was change the connector on the aileron servo connector. That was it. So then on to the modification portion. And on the modification portion, once you get your motor and gearbox assembly removed, the 12x6 motor, it's a large enough diameter that you're going to have some problems with the foam right on the tip of the nose. So what you're going to want to do, and I just took a utility blade and I cleared just a thin layer around the nose of that. I made the front of that foam very, very thin, cutting all the foam around it, so I had plenty of clearance to each side, above and below the motor. And then there's going to be some extraneous foam in there as well, where the foam was molded to hold the stock motor and gearbox in there. So I cut all that free too. And so you want the sides of the inside of the fuselage nice and smooth. You don't want any of that foam protruding because that's going to interfere with the motor mount. So once all that is cleared out and you've got the inside of the fuselage nice and clean, and you can just, you're going to have to pry the two halves of the front of your fuselage apart a little bit to be able to get to all that. So once that's done, I just used some foam tack and one of these cheap little paint brushes, and I painted the inside of the foam on the fuselage all the way back to about halfway to these little fake exhaust pipes on the side of it. So I went about all the way to here, all the way to the nose, and I basically painted that with glue on the inside. And the reason I did that was because I wanted to strengthen that glue where that motor mount was going to go. And then to strengthen the outside of the foam around the nose, I also, once I got everything glued together, I took a little bit of glue and I just painted some glue on the outside of the very nose where it's really thin, so that none of the foam will be ripping on you or peeling or anything. So I basically made that pretty rigid on the nose by just painting it with glue, and that worked out really well. On the fabrication portion, I started out with the motor mount template. Now, you don't have to use my motor mount template. You can make your own template. This is just what I started with. I used M3 nylon screws as the screws to hold the motor mount in. As you can see, the nuts on the outside of it right here. So I just bent back, in a U shape. You can see the picture of the motor attached to the motor mount. And then in the next image, you'll see the screws, the nylon screws, mounted in the bottom. And so I basically just bent back the sides of the plastic, where it was a little bit larger diameter than the motor when it's mounted. Because you don't want to pull the foam in when you put the motor mount in. You want the motor mount to hold the foam in where it is when you tighten it down. So just a little bit larger than the diameter of the motor, and since I was going to be using 3mm diameter nylon screws to attach this to the fuselage, I wanted to have enough of the plastic material, and this was just made out of plastic gift card material. That is the one piece of junk mail I really enjoy getting, is when they send me one of those plastic, fake cards, because that's build material for me. So that's what the motor mount is made out of, and that's what the mount plates on the side of the fuselage are made out of. It's just a plastic gift card. So I wanted to bend back enough material that it was going to have enough strength after drilling a 3mm hole through it for those nylon screws that it wasn't going to bend and it wasn't going to flex real easily. So I probably left about, I would say I bent back about 15 millimeters of material, and then just drilled a hole through the center of it for the nylon screws. And then I super glued the heads of the nylon screws to those plastic tabs that I bent back, so that when I'm putting the nuts on the outside of it, the screws are not going to turn and they're not going to back out. You know, they're going to be part of that mount now that I've super glued them on there. And that's the way I wanted to do that. Now, if you look at the side plates that I fabricated, and those are made out of the exact same material, I made the hole, the 3mm hole that I drilled in, I made it like a slot. You know, it's elongated. And the reason that I did that was I wanted to have enough room, because you can't move your battery around for a ballast to get your CG. So what I wanted to do was have enough space that I could move the motor forward or I could move it back inside those side plates, and to get my balance right on the CG. And what that also does is it allows me to provide a side angle, you know, by just pulling one side further forward than the other side. It allows me to put angle into the motor either to the left or to the right, because these props are made for quadcopters. They come in clockwise and counterclockwise, and I want to be able to use all the props, right? So I can loosen these screws up, these mount nuts on the screws, and then I can change my angle either left or right. So I can use a counterclockwise spinning prop or a clockwise spinning prop. So you get to use all those multi-rotor props. And since it will pivot on these up and down, it also allows me to be able to put either up angle in the motor or down angle in the motor. Now, I've never had to put up angle in a motor, but I've had to put down angle into motors lots of times, and this one has a bit of down angle in it, so that when it picks up speed, it doesn't continually climb, it holds its line. So I've never made a motor mount like this before, but it turned out to be extremely versatile in that I can get left angle on the motor, right angle on the motor, and as much or as little down angle as I need, just by loosening up these nylon nuts and then moving the motor. Well, basically the entire mount, moving the mount. And so that works out really, really well. So in the next step, once your super glue is set up and you've got your motor mounted on the plate, and you got your nylon screws glued into the holes that you made in the tabs that you bent back for the motor mount, then you want to create your side plates, your fuselage plates, your mount plates, and then just do what I did. You know, I would say that these plates, you probably wouldn't have to make them as long as I did, but I wanted to make sure I had enough strength. But I would say that these are probably about 25 millimeters in length. You could probably cut those back to 20 millimeter and you'll be just fine. But don't forget to cut your slots in there. And where I positioned these plates was, you know, I took my motor and I looked where the screws were located, and I wanted to make sure that when I located the side plates that I had room to move the motor forward and I had room to move the motor back. So I looked at, you know, putting the motor in where I had about, I'd say I got about 4 millimeters of clearance between the prop and the foam on the nose of at the end of the fuselage, about 4 millimeters of clearance. So I wanted to make sure that when I installed the side plates, that those screws were going to be right in the center of that slot, so that if I needed to, I could move the motor forward or I could move the motor back. So, and that gives you a little bit of room to adjust your CG. So that's what I would do. All right, so then on to fabricating the saddle mount. I fabricated a saddle mount to go over across, to be glued on top of a little horizontal section of foam right underneath the wing plate. And the reason I did that was because I wanted to use a small screw. I wanted to attach the front of the wing plate. I wanted to secure it with a screw. So by making that little plastic saddle mount, that U-shaped saddle mount, I glue that over the top of that horizontal section of foam. And then I let that set up. And then when I reattach my wing, there's a little horizontal support inside by the latch where the battery hatch closes. And what I did was I just drilled a tiny hole in that, and then a little tiny pilot hole in that plastic saddle mount that I installed. And then I used an extremely small coarse thread metal screw. And that's what I used to secure the front of the wing to the fuselage, and it worked out great. So I like that. Now, the other thing that I did was I took 20 millimeter sections of 2 millimeter diameter carbon rod. I wanted to use something that was rigid, but something that was very lightweight. And so on the back of the wing, where you see this, where I was talking about that raised portion for the air intake, well, there's a lot of foam there. So what I did was I just came in about 5 millimeters on either side of the wing where that raised portion is. And I embedded 10 millimeters of that 2 millimeter carbon rod into that foam. And that's going to serve as my wing pins on the back of the wing to embed into the fuselage foam, on the mating piece of foam here. And that's going to secure the back of the wing plate. So once those were inset, what I did was I just took some magic marker and just marked up the very ends of that carbon rod, and then just set it in nice and straight, seated it all the way, and then push those pins up against the back of the mating foam right here. And then it left two little black dots. So those two little black dots were my guide for drilling out 2 millimeters of foam, about 10 millimeters deep, into the back side of the fuselage, so that the pins will slide easily in there and secure everything in the back of the wing. And so that's how I secured the wing, just with 2 carbon pins embedded in the back of the foam on the wing, and then 2 guide holes on the back side of the fuselage, in this portion here, for them to slide into, and then a screw on the front of the wing. And that worked out really well. You've seen it fly. So it holds the wing nice and snug against the fuselage, so you don't have any worries about that. That will hold it absolutely fine. So this is where you're going to install your motor. Once you've got your plates fabricated, you've got your slots cut, you got them positioned correctly, you've glued them to the fuselage, and I use the same glue I always use on foam planes, all different types of foam, and that's either foam cure, foam tack, or in some instances hot glue. Okay, so once those are all set up, then it's time to install your motor. And like I said, I have my motor installed, so there's about 4 millimeters, and you want to attach the prop to it. It's a lot easier for me to see the angle on the motor if I've got the prop attached to it. So I always attach the prop to the motor when I'm installing the motor and the mount in there. Okay, so once you get it installed in the holes in the slots of your side plates, your mount plates here, go ahead and put your nuts on and just tension it down a little bit, not too much that you can't move the mount, but enough to hold it in place. Okay, so you want to position that motor, and if you're using a counterclockwise rotating prop, you want a little bit of right angle in it. If you're using a clockwise rotating prop, you want to use a little bit of left angle in it to counteract the torque of the motor of the prop. So since I have a counter-rotating prop, I made sure that I had just a slight amount, just a very slight amount of right angle in the motor. Probably like, I can't imagine that that's probably more than a half a degree of angle. And yeah, that's all it took, because my rolls going counter torque are just as quick as the rolls going with the torque. So that tells me I've got about the right amount of right angle in it. Now, I did put more down angle in it. If you can see in the camera how much down angle I have, I would say I have a full degree of down angle in that prop, and you're just going to have to test it, you know, and see. You know, test your rolls, and if your roll going against the torque of the motor is slower than it is going with the torque, then you'll need just a slight amount of more right angle in the motor. If once you get your plane trimmed out, if you do speed runs with it, and on your speed runs, if the plane is zooming on you, you know, it wants to nose up and climb. When you power up the full throttle, you need more down angle in it, and just keep adjusting that until the plane flies nice and straight when you're going full throttle, and it's also holding the wings straight and level when you're going full throttle, and that your rolls to the right and to the left are symmetrical. Then you'll know that you got your angle working properly on your motor. Okay, so once you get that installed, once you get that set up, then it's time to go ahead and glue the seams on your fuselage before we install the wing, before we install the servos. We want to get this nose rigid. So what I did was I got that all adjusted where I thought is, you know, where I needed it, and then I secured the motor mount and then glued the seams, you know, that I cut top and bottom over here. And then I just took rubber bands and I put a rubber band across the, you know, 3 different rubber bands, one on the very nose, one in the middle, and one as far back as I could get it, so that it would hold everything in place until the glue set up. So, and it kept it formed very well. You know, it looks like all the foam looks like it should. You know, it's not, the seams match up really, really nice. Just like it did before I cut it up, you know, so that's what I did. All right, so, and then once that's done, then it was time to install my servos. I use 1.7 gram digital servos. I don't care for analog servos. They never seem to hold their position very well. So I like using digital servos. So, and I'll put pictures up there again. But I wrapped this body of the servos up in that blue painter's tape. And the reason I did that, because I used hot glue to attach the servos, because I didn't have time, you know, to clamp it and hold it in place and wait for the glue to set up. So I used hot glue to secure the servos inside to the side of the fuselage. And I put painter's tape around it before I glued it, so that if I ever need to get the servos out, all I got to do is cut the tape and peel the tape off. It'll be a lot easier to get the servo out and then put a new servo in if I'm not having to pry the entire servo loose from the glue, and then have to clean up the servo. So we've published. I'm not going to tell you how to do this now, but I made sure I centered up my servos before I installed them. I had published a video on centering up servos, so just do a search for that on our YouTube channel, you'll find it. It's a good tutorial to see how to center up your servos. So once I centered up the servos and have the servo arms right in the center, then it was time to attach the control linkages to the servos before I glued them to the side of the fuselage. Because what I did was I clamped the elevator and the rudder into a completely neutral position. I just used a couple of pieces of that plastic cardstock and a spring clip to hold the servo in the center position, the elevator in the center position. I have my servo arms in the center position, so that when I glue the servos to the sides of the fuselage, everything is in a neutral position. And so then when I program my radio, I'm going to have symmetrical movement on the rudder, left and right, symmetrical movement on the elevator, up and down, which is what you want. So once that's done, then, you know, connect all your wiring to your receiver and your speed controller to your motor, and then get everything programmed in. It doesn't have to be perfect, but just make sure all the electronics are plugged into the receiver and everything is working, that your motor will spin up. Make sure you don't have the prop on it when you're testing your motor, programming your radio. I always take mine off. Make sure your motor's spinning in the right direction. before you put your wing on, because you want to be able to, you know, change, if you need to change your connection on your wires between the motor and the ESC, that's the time to do it before you attach your wing. So make sure your motor's spinning in the right direction, make sure all your servos are working properly, moving in the right direction, and then once you've confirmed that everything's working correctly, then it's time to seat your receiver in your ESC and attach your main wing. And my receiver and ESC, you won't be able to see it on camera. If you could look through that little slot in that air intake, you'll be able to see it. Because my receiver and my ESC are sitting right here in this raised portion of this little air intake on the bottom. And that's about as far back as I could put mine and still get my motor wires back to the ESC. But that I wanted to put it back here so that I had good balance on the CG once I put my 360 milliamp hour 1S LiPo in it. And my CG is right in front of the main wing spar. I think I would actually like to have my CG right on the main wing spar, because my test flights felt like it was just ever so slightly nose heavy. And I mean just a tiny, tiny bit. But I like a very neutral balance on my plane, so I think, you know, I've got 4 millimeters of clearance between my prop and the nose of the fuselage. So I think I'm going to move the motor back about 3 millimeters to get my CG right on that wing spar for a neutral balance, and I think I'll have my CG exactly where I want it. But anyway, once you get everything working, go ahead and seat your pins for your wing into the fuselage, run your steel screw in to secure your wing, and now you're ready to program your radio for your dual rate, your expo. Make sure that you're getting the right amount of movement in all your control surfaces. All your control surfaces are moving in the right direction. Once you confirm everything's working properly, then go ahead and mount your prop on your plane. So I have provided already a setup sheet for this brushless conversion on how I have my control surface movement and expo set up. So if you haven't downloaded that, you might want to download that, take a look at it. It'll give you the amount of movement you should have on your rudder, your elevator, your ailerons, and how much expo I have dialed in to my rudder, my elevator, and my ailerons. And if you've watched test flight session 3 with this plane after the brushless conversion, it flies very smooth. I have enough expo to make everything nice and smooth, and I have enough movement on all control surfaces that I can do all kinds of aerobatics with it. So take a look at that video if you haven't watched it yet, and you'll see what I mean. So if you set yours up the same way, it should fly just like mine. It will at least give you a good maiden flight, and then you can adjust for your flying style from that point. Oh, and now my time is up. So next, in about a week, I should have Group 6 of my OpenTX model files published, and that will include the model file for this plane from my TX16S transmitter. So I hope between this show and tell and the downloadable build log, I hope that answers your questions. Hopefully that's enough information that you guys will successfully be able to do a brushless conversion of this plane or any other plane. So anyway, thanks for watching, and I will see you in the air.